Assalamu alaikum, guys. In today's lecture means the sixth lecture of this topic, uh, work, power, and energy. We are going to do law of conservation of energy. Okay. So, what is the statement of the law of conservation of energy? Yes. So, law of conservation of energy states that energy, energy cannot be neither can be neither wait, and that energy can be neither or neither be created nor destroyed, okay, but it can be converted from one form to another. Okay, so energy can be neither created nor destroyed, but it can be converted from one form to another. So this is the statement of law of conservation of energy, which is very important. Okay, which we should be which we should learn. Okay, so how is it possible? So when sorry. Okay, so let's suppose here is a pendulum. Okay, pendulum, and it moves up. Okay, here. So what happens when it moves up? So over here with the base, its gravitational potential energy is zero. Okay, while at the top it becomes maximum. Okay, it gains GP. Okay, means gravitational potential energy. Okay, so this is the extreme position, and when it again goes down, what happens over here? The Ke becomes maximum, okay, and GP is zero. And again, if it goes up again, then what happens? That here GPE becomes maximum because it gains height, hence it gains height, hence it increases. Okay, as you can see that it gains height, so hence it will be maximum, while kinetic energy will be zero. Okay, so this is called the extreme position, and this is called the mean position. Okay, mean position. Okay, so we are done with this, that how it is converted. Okay, so when it goes up, the energy converts to kinetic to cheap gravitational potential energy. When it comes down over here in this stage, it the gravitational potential energy is equal to zero and kinetic energy is maximum. And again, if it goes up, the gravitational potential energy is maximum due to the height, and K is equal to zero. Okay, so let's write some major energy conversion. Okay, so let's write some major energy conversions. Okay, so what are some major energy conversions? Let's take an object falling from certain height, okay, from a floor, on a floor. So in this conversion, what happens that gravitational potential energy, because it's elevated. So what is gravitational potential energy? The energy stored due to its vertically elevation. Basically, gravitational potential energy means this. Okay, so it's from a height. So when it falls, it faces air resistance, and at the collision time, it also faces friction, which causes heat to be produced, and okay, and kinetic energy is also produced, and sound when it hits the ground, a sound is also produced. Okay, so this is the first major energy conversion. So this is how gravitational potential energy converts from to heat and to kinetic energy and to sound when an object is falling. Okay, Okay, so what's the second example? Second major energy conversion. So it can be a cyclist riding the bicycle up the hill. Okay, because in this, what happens is the cyclist is using his chemical energy, which which is then transferred to kinetic energy. Okay, and gravitational potential energy. Okay, and with it, because there is a friction, hence on in the tires and in his body also, heat energy is also created. Okay, so this is also that how a chemical energy can be transferred. Okay, now let's do the third example of transferring, and it is an object released from catapult. Okay, and that object hitting the target. Okay, so in this example, the elastic energy is transferred into kinetic energy, and so in this example, the elastic energy is transferred to kinetic energy and sound energy and heat energy. Okay, so these three are the conversions of energy. That how does elastic energy? Like for example, let me draw it also. Like this is the catapult, and here is the arrow. Okay, so this is the arrow, and this hitting at the target. Okay, so this is how it is done. You got it? So this is the drawing of this example. Release from the catapult and hit it on the target. Okay, so now the fourth. Okay, fourth. Which is the fourth? To switch on filament lamp connected to battery. Okay, so in this, wait, let me write. To switch on the filament lamp connected to battery. Wait, okay. So in this, what has happened? That in this example, the chemical energy, okay, chemical energy is transferred into electrical energy, and that energy is transferred into light energy. Okay, light plus heat energy. Okay, you got it. So in this, for example, in this fourth example, it shows this that how the energy has been transferred from chemical energy to electrical, and then from electrical to light and heat. Okay, so we're done with the fourth example of conversion. Let's do the last and fifth example, which is a person, uh, or let's take the example of wait, let me think about an example. Yeah, a person knocking the nail into the wood with hammer. Okay, this is the last and fifth example. A person knocking the nail into the wood with hammer. Okay, hammer. So in this example, what happens is that chemical energy, chemical energy is converted into gravitational potential energy because gravitational potential energy because first the hammer has to be lifted. Okay, wait, first the hammer has to be lifted. Okay, so this lifting cause this GPE to be stored in it. Okay, in this hammer, and then what happens is that uh, that gravitational potential energy is turned to kinetic energy. Okay, and that kinetic energy is turned to sound, and with kinetic energy, sound and heat is produced. Okay, so when it will hit the nail, it will produce sound and heat, and while it is moving, it will produce it is doing K. It is using K. Or it is in a system of kinetic energy. Okay, production of electricity. Now we'll do the production of electricity. So how is so there are many ways in which electricity can be produced. Okay, there are many ways in which electricity can be produced. So in production of electricity, we do the burning of coal and oil. Okay, so how is it done? That in coal, chemical energy is stored. So when we burn it, okay, chemical energy, what is produced? Heat is produced, right? So first, chemical energy is transferred into heat, and that heat is used uh, to heat the water, which turns into steam. Okay, and due to that steam, kinetic energy is produced. Okay, the moving of steam, and that movement causes the to produce electricity, causes the turbine to move. Okay, electricity. So that movement causes the turbine to move. So we are done with the burning of coal. Now let's do hydroelectric generation. So hydroelectric generation is done like, for example, this water is stored over here. Okay. So when this water is allowed to go to pass, it has gravitational potential energy stored because it is in an elevated place. Okay. Stored in an elevated place. So here GPE is stored. Okay, gravitational potential energy is stored. So that energy transferred to kinetic energy, the moving of water is to be known as kinetic energy, and that moving of energy causes here a turbine is placed, and that turbine moves due to this flow of water. Okay, and hence electricity is produced. So in windmills, what happens is that wind energy, okay, wind energy is transferred into kinetic energy. Okay, and that kinetic energy makes these what we call them, this fan kind of structure to move. Okay, these windmills to move, this cause the wind causes it to move. Okay, because they are made in this style that when wind starts, they start to move. Okay, and they produce electricity. So when these fans move, inside it a turbine is produced, which also starts moving. So nuclear power generation. So how, so in nuclear power generation, nuclear energy is transferred into heat energy. Okay, first heat energy, because due to the nuclear fission or fusion, a lot of heat is produced. So due to that heat, water is boiled and steam is produced, and from steam energy, from steam, what happens that that steam is readily moving. So kinetic energy is produced, and that kinetic energy moves the turbine, making electrical energy. So in solar energy, what happens is that solar energy is mm, transferred into electrical energy. Okay. So in geothermal energy, what happens is that heat energy is means the heat of the earth. Okay. Heat energy, wi- heat of the earth is transferred into steam. Means it is given to water, and that water is transferred into steam, and steam is moving. So hence it has kinetic energy, and that kinetic energy moves the turbine, making electricity. Okay. So that's all for today, guys. So in the next lecture, we will try to do the block diagram, also the environmental issues of power generation, and what are renewable and non-renewable resources, and we will also do Einstein's mass energy relationship. Okay, so stay tuned, and and inshallah we'll upload that other lecture tomorrow, inshallah. So be ready for the next lecture. Allah Hafiz.